get started here. All right. Graphing functions. So our objectives, and you see we got a lot of objectives we need to get through today. The key is we're going to be graphing nonlinear functions, understanding the domains and the ranges. Our Indiana academic standards. All right, objective 1. Find function values graphically. So we're going to be able to look at a graph. So here's a graph, and I say, what is f of negative 3? Guys, what is f of negative 3 by looking at the graph? What is it? 5. It's the output, right? What is f of 0? 2. Okay, now look at this one. Find the value of x for which the function is equal to negative 2. So we have to go down and look at the graph. Where does the graph have a y value that's negative 2? At x equals 4. So does everybody see how we answer part B at when x equals 4? And my pen is white. I need to probably change my color. That would probably help. All right. Okay. Let's continue on. Finding the domain and the range. Now this is a linear function. So this is going on forever and ever. So the domain would be all x values, all real numbers. And you would say that how in interval notation from negative infinity to infinity. And the range is going also, the y values from negative infinity to infinity. But we're going to look at some that are not going to be quite as simple as that. We're also going to be talking about graphing nonlinear functions. We're going to graph parabolas. We're going to graph cubics. We're going to graph absolute value functions. And I bet you have before, but we want to make sure we feel good about this. A common parabola. If we're graphing a parabola, we know, and we're not going to go into detail to graph a parabola, but we know the vertex is at 0, 0. Would everybody agree with that? If I plugged in 1, what's 1 squared? 1. If I plugged in negative 1, what's negative 1 squared? 1. If I plugged in 2, what's 2 squared? 4. If I plugged in negative 2, what's negative 2 quantity squared? 4. There's a quick graph, and I want some points because I need to know the values, and we have a U shape of this. Okay? Now what we're also going to do is you're going to tell me the domain and the range. What's the domain? If we look up here, even though it's going up, the x's are going from negative infinity to infinity. You guys feel good about that? What's the range? And what you have to do is you have to think first y value. So you go from starting down, first y value, and then keep going. So the range would be, Charlie?
It'd be a bracket.
Inclusively.
And 0, to infinity.
Very good. Inclusively 0 to infinity. Very good. You okay with that? All right. Good. Okay, absolute value graphs. Let's plug in 0. What's the absolute value of 0, guys? 0. What's the absolute value of 1? Absolute value of 2. Absolute value of 3. And so forth. So we do this. Straight line. It's linear. But then also, what's the absolute value of negative 1? 1. Absolute value of negative 2. 2. And so forth. So again, very similar to a parabola. Oh my goodness, I lost it. Very similar to a parabola, except it's a linear versus a quadratic. And domain, Cole, what would the domain be? Negative infinity to positive infinity. Very good. And our range would be what, Mr. Coyne? Inclusively 0 to infinity. So just like the parabola to start with, right? Okay. Next graph. X cubed. Okay? Well, let's start with 0. What's 0 cubed? 0. What's 1 cubed? 1. What's 2 cubed? 2 comma 8. So we've got a big jump now, don't we? 2 comma 8. All right, so we have this shape. It's taking off. Let's go the other way. What's negative 1 cubed? It would be negative 1. So it's down here. What's negative 2 cubed? Negative 8. So this would be the graph of our cubic function. Agree? Okay. Caden, what would the domain of this function be?
Negative, positive infinity.
That's right. It's from negative infinity to positive infinity. And be careful. Even though it's taking off very quickly down, it can keep going. The x values can keep going forever and ever. And, Ms. Duffy, what's our range? And think y values. Careful, Ms. Duffy, look up here. Doesn't it go below 8, negative 8? Doesn't it keep going all the way to infinity? And doesn't it keep going all the way to infinity? So the range is also, Kirsten? That's right, negative infinity to positive infinity. Good. All right. Now, let's talk about some shifts. All right. So the first one, we're going to talk about vertical and horizontal shifts. It shifts up if I have the function plus k. It shifts down if I have the function minus k. Now look here. Within the parentheses, if the function is x minus h, it shifts to the right h units. But if it's x plus h, it shifts to the left h units. It's the same for the vertical. It's the opposite for the horizontal. I feel confident my sophomores have seen this last year in Honors Algebra 1. Is that a safe assumption? What about my 8th graders and my freshmen? Have you seen this? Shifts. Okay, so let's make sure. Let's look at it. So there's those rules that I just talked about. So there's a up, down, left, right. Let's look at it. So this is x squared plus 2. We know what the shape is. It's a what? What kind of shape is x squared? It's a what? Parabola. It's a parabola, right? That's been shifted. This is a vertical shift. So how's it been shifted, guys? Up 2. So we're going to shift it up 2 units. I'm going to real quick hit. There we go. So we're going to shift it. So now my new graph, instead of being at 0, 0, has been shifted up 2 units. So now it's at 0, 2. And it's the exact same shape, except everything has been shifted up 2 units. There's my parabola. Let's just say it. We won't write it. I want you to write it, but let's just say it. Ms. Durbin, Lauren, what's my domain? Okay, but look, hon, doesn't this graph keep going? And won't it keep working out? Couldn't I find the value? Negative 6 squared, 36 plus 2. It'd be negative 6 comma 38 way up here. So the domain would be, Ms. Durbin? Trying to help you out here. This arrow is going all the way to that way. That's as far as it will go on the screen, but pretend that's infinity over here. Okay? So it would be, that's right, negative infinity. The x value can be anything. So it's negative infinity to infinity. But the range, Peyton, what's the range? Very good. Inclusively, that's where the y value starts to infinity. Cool? Okay, that's an absolute value, so it's a V shape that's been shifted. What's this right here do? So what's that do? Jacob, what's this do right here? Shifts it how?
It shifts it.
Here, we'll go to this one. What's this do?
That one shifts down.
Down 4. Good. Okay, now I'm sticking with you, Jacob, because you're smart. Okay, notice I didn't call him Cole. Okay, this I'm teasing Cole.
Shifts to the left.
No.
Oh.
Right, it's opposite for the X. So right 1, down 4. So that vertex, instead of being at 0, 0, is going to go right 1, down 4. So here's my vertex. Exact same shape. So it's doing this. There. And there. Sam, what's my domain? I love it. Negative infinity to infinity. Good. And who wants the range? Who wants the range? Okay. Seth, what's the range?
Inclusively -4 to infinity.
Perfect. Inclusively -4 to infinity. Nice. Okay. Domain, range. We good? Let's do another one. Oh, let's hit pause then. So here's x squared. Here's negative x squared. What it does is it reflects it over the x-axis. It gives a vertical reflection. So let's do an example. Okay? So we already just saw that one on the board, so let's not do that one. But let's do one a little bit more complicated here. I have a parabola that's reflected, shifted right 2, and up 1. Does everybody follow me on that? So it's reflected, right 2, up 1. Here's how I'd approach it. So we were going to have the point 0, 0. It's reflected down, and then we go right 2, up 1. So that vertex, if you will, of this parabola is here at 2, 1. Because it's been reflected, shifted right 2, up 1. Does everybody understand that that's my parabola? From here, it's going to be a parabola that opens down. So here's points, and here are the other points. So, is everybody comfortable with that? Then I would go 2 here and 4 this way. So the other point would be here at here and here. And you're going, Mr. Dice, how do you know that's where the points go? Well, let me go back and do this. Let me graph in a different color. The original parabola that we talked about, y equals x squared, is this. So I'm going to draw it in blue. The original parabola, y equals x squared, is in blue. I am not going to ask you to graph the original function. Okay? You should know what the original function is. But it's this. We talked about those points. I did it right at the beginning. There's its parent function, if you will. That's y equals x squared. Now let's look at it. So, look at this point. Has it been shifted right 2, up 1? Look at this point. Has it been shifted right 2? And sorry, I got to do this. The first thing I got to do with this point is I have to reflect it down to here, and then right 2, up 1. See that? So look at this point. The first thing I have to do is reflect it down, and then right 2, up 1. Did that help understand it a little bit? Okay. Good. So you guys, with the people around you, and see if you can graph y equals negative x cubed minus. Okay, so it's been reflected and then shifted what? Down 2. Okay, so I'm going to go back to my red. So that, you have a point here. Now let's see if you're on top of it. I think it's doing this now, isn't it? And here at 2 comma negative 10, and here at negative 2 comma 6. Does that look right? Because it's been reflected. Let me draw it. It's been reflected. So wasn't the original one going up from left to right? But since it's been reflected, it's going down from left to right. And every point has been shifted down 2 units. Do you have the same points as mine? Okay, and that's how I'm going to be able to tell. Are your points going through the same thing as mine? Now let's talk about this one real quick. The domain is from negative infinity to infinity. The range is from negative infinity to infinity. Now I don't still have the graph of the previous one, but I think I could graph it real quick. Let's see, it's been shifted right 2, up 1, and it's been reflected. So I think it was here. It was doing something like this, right? Was it doing something like that? Okay, what was this domain? Negative infinity to infinity. But what was this one's range? Ms. Swango?
It'd be a negative infinity,
2,
1.
inclusively 1. Cool? Okay. Using vertical line test to tell if I have a function. So look at this one. And I think we already talked about it. This is not a function. It fails the vertical line test. Why? Well, so say I have this point. What's this point right here? 0 comma what? 4. And what's this point? 0 comma. Same input, 2 different outputs. Fails the vertical line test because it hits the graph in more than one place. See here how it passes the vertical line test? You want to continue talking about the functions. Okay? So, and then next thing I want to talk about is piecewise functions. Here we go. Last part. All right. So if I ask this question, I give you a function that's in pieces. It's this graph when x is less than 0, and it's this graph when I have x greater than or equal to 0. So it looks like it's 2 different graphs, okay? And I ask you, what's f of 2? Well, first of all, is 2 less than 0 or greater than or equal to 0? Greater than. So you plug it into this one. What's 2 minus 3? Negative 1. So the answer is negative 1. I can always tell when a student really doesn't understand it when they give me 2 answers. They plug it in both of them. That would tell me you don't know what you're doing. Is that fair? Okay. So on f of negative 3 is negative 3 is definitely less than 0. Everybody agree? So negative 2 times negative 3 would be 6 plus 1, which is 7. And f of 0, well, since it says equal to 0, I plug it in here, and 0 minus 3 is negative 3. Everybody good? Okay. So now let's graph it. We already talked about it. Let's graph it. So it's this graph when x is less than 0. Here's how you do it. Ready? You plug in 0 first. So everybody follow me up here. What's negative 2 times 0? 0. What's 0 plus 1? 1. So I have a point at 0 comma 1, but I'm going to leave it open. Mr. Dice, why did you leave that? Why did you make that circle an open circle? Okay. It's not equal to 0. It's less than 0, which means less than 0 means, look at my cursor, I need to graph this line to the left of 0. Question, what's my slope? Negative 2. What graph has a negative 2 slope? One that goes up 2, left 1. Up 2, left 1. The biggest mistake I see students make is they draw a positive slope. They go down 2, left 1. Isn't negative or negative positive? And I draw this graph Well, I draw this graph here. Doggone it. There. Now I'm going to do a different color for the other piece. You don't have to, but my other piece, I'm going to graph x minus 3. I'm going to plug in 0 again. What's 0 minus 3? Negative 3. This time, I'm going to make this a closed circle because it's equal to. What's the slope of this line? 1. I'm graphing it to the right of 0, so I'm going to go up 1 over 1, up 1 over 1, just like this. Boom. There's my graph. Okay, ready? What's my domain? It's going to keep on going. Open circle, but it jumps to a closed. Keeps on going. The domain is negative infinity to infinity. Now the range, not quite so simple. Let's follow the range. Yeah, you have a question?
Yeah, so for the x is less than 0, so the first point is an open circle, but then everything else is closed?
Yeah, because it's open because it's not equal to 0, but everything to the left of 0 is solidified it. Does that make sense?
Yes.
And we have to have it a function. So look up here. It would fail the vertical line test if I had these both being closed, because then I'd have 2 points, and that's a function. So it has to pass the vertical line test. Everybody clear on that? If your graph doesn't pass the vertical line test, you did something wrong. Now the range. Where's my first y value? Right here. And then it keeps on going forever. Everybody agree? So it would be inclusively negative 3 to infinity. I feel like we should do another example. Okay? So this graph has 3 parts to it. It's this graph when x is less than negative 2. So follow me. I'll do each part in a different color, okay? First thing you do is you plug in negative 2. Guys, what's 2 times negative 2? 0. Excuse me, I worked ahead. Negative 4 plus 4, which is 0. So on our graph, negative 2, comma, 0. And why is it an open circle? Because it's not equal to. We're graphing points that are less than negative 2. So which way am I going? To the left. What's the slope of this line? 2. How do I go to the left and graph a positive slope? Down 2, then what? Left 1. Isn't a negative over a negative positive? Down 2, left 1. And again, it's solid because we're graphing the values to the left of negative 2. Is everybody comfortable with the blue line? Now this middle part, I will use a red ink. So this is my red graph. This is my red. Okay? I'm going to graph the line negative 1/2 x minus 2 between negative 2 to 0. Here's what you do. Look at this point right here. Plug in negative 2. Negative 1/2 times negative 2, 1. 1 minus 2, negative 1. So negative 2 comma negative 1. Open or close, guys? Close because it's equal to. Now here's what I recommend. Plug in the endpoint 0. Plug it in. That gives me 0 minus 2, which is negative 2. Why is that circle open? I know it's hard to see. Why that's an open circle. Why is this one open? Because it's not equal to. Now, look at this. Connect those 2 points. Straight line. Come back up here. What was the slope of this line? Negative 1/2. Look at this, guys. Down 1, right 2. Last part. Plug in 0. Wait a minute. There's no x. What is that? That's a what? that's a horizontal line with every value being 3. So I'm going to do this. It's closed because it said it's equal to 0, and then greater than would be this. Cool? All right. Now, you guys think you could find the domain? You guys take a moment, see if you can determine the domain and range. Talk to the people around you, discuss it. And I'll swoop in here and show you why you're wrong and I'm right. I think we all can agree the domain is from negative infinity to infinity. Who feels really, really confident with the range? Cole, I'll go ahead and let you get it wrong. All right, so what do you think?
Okay, so I think it's 3 inclusively. No, it's negative infinity and then 3 inclusively.
So it's from negative infinity to 3 inclusively?
Yeah.
Okay, wrong. Because look, do we have a range value of 2? Oh. It's from negative infinity up to what? 0. Exclusively. And, or you can use either one. What else? Just what? Just 3. I would do it like that. And just the value 3. That's a tricky one. Does everybody see it? From